All right, let's look at some examples. Again, we're still in lesson 1.11 here on just how we can use scientific notation to help us with some real life problems. So this is talking about the U.S. national debt as of 2013, so a few years ago. And we were well over 16 billion, pushing 17 billion. And then for our citizens here, let's see, that's 313 million. So what was each citizen's approximate share of the debt? So I want to know basically per person, their unit rate. So in that case, I'm going to divide. I want to take the total debt and divide it per person. That'll give me the debt per person, per one citizen. So like we've been doing, I'm going to break this up. 1.6755 over 3.14. Already had it set up like that. Times 10 to the 13th over 10 to the 8th. So again, using a calculator, we're going to do some approximating. Okay, and this is the purpose of scientific notation. It doesn't need to be down to the penny for something like this when we want the approximate share of the debt. So we're going to say it's approximately equal to 0.53358987. Okay, round it a little bit there. Times 10 to the same base dividing, we subtract the exponents. So that's to the fifth. Not in scientific notation though. So remember, I want to take my decimal point and I want to put it right here. And I'm going to say that this is approximately 5.33, I don't know. I might round here again. Make that 6 times 10. And if I go from where I want it to where it is, I'm moving 1 to the left. That's a negative direction, so I'm going to subtract 1. Bigger by a power of 10, smaller by a power of 10. So we could say it is 5.336 times 10 to the 4th, or if we make this in standard form, one more, I have to add a 0 in there, it would be $53,360 of debt per citizen. Ouch. Okay. So we could approximately figure out how much debt per citizen we have here using scientific notation. Okay, another example. Feel free, guys, if I'm again going too fast and you miss something, or feel free to pause, rewind, do what you need to do. All right, this one here, I'm gonna erase this off so we don't get distracted. The geographical area of California is 163,696 square feet. The United States is 3,794,101 square feet. And they've given us what it is in scientific notation. In terms of area, roughly estimate how many Californias would make up one US. So how many times would California fit into the United States? So again, let's say California was 10 square miles and the United States was 20 square miles. How many Californias would fit into the United States? Well, to figure out how many times it fits in there, we need to divide. All right, so I'm going to put the United States on top. I'm going to put the bigger one on top. Now, if they were given to us, you don't get to switch it around bigger and smaller. But if I want to figure out how many Californias fit into the US, I need to put US on top. I need to put the bigger one on top. I look at the exponents. This is bigger. So 3.794 times 10 to the 6th divided by 1.637 times 10 to the 5th. Okay. And as always, I'm going to break this up and take each part separately. Now, I've already done this division, okay? And I'm going to say it's approximately equal, just type that into a calculator, 2.318 times, this is a 10 here, not a 6. Sorry if it looks like a 6. Same base dividing, we subtract the exponent. 6 minus 5 is 1. So this one, you kind of could put it in standard form right away, moving it 1 to the right because you're just multiplying by 10. And I could just say it's approximately approximately, well, it ends up being 23 Californias. Would make up the US. In my sloppy writing here, sorry. Okay. All right, let's look at one more example. The average distance from Earth to Moon is about 3.84 times 10 to the fifth kilometers. Distance from Earth to Mars is 9.24 times 10 to the seventh kilometers. So on the simplistic level, how much further is it traveling from Earth to the Mars than Earth to the Moon? How much farther? Well, if we want to figure out how much farther something is, if it was 90 miles to the moon or to Mars and it was 30 miles to the moon, how much further is it? Well, we would subtract. So that's what we want to do here. So this will be a good chance for us to work on our subtraction skills. So I'm going to look at my exponents here. It's longer to Mars. So I'm going to go 9.24 times 10 to the seventh. So I'm rushing, getting sloppy. Minus 3.84 times 10 to the fifth. Now, adding and subtracting, we have to have the same power of 10. We don't have that here, so I'm going to go break them down into the smaller one, and I want to rewrite this with a 10 to the fifth. Well, that would make this 10 to the second. Same base multiplying, we add the exponents. So I'm only going to focus on this problem right here, and I want to do this part first. So just like we've done in the past, there we go. 10 to the second is 10 times 10 or 100. So if I take 9.24 and I times by 100, whether you can see it, whether you put it on the calculator, doesn't matter. This becomes 924, takes care of all of this. Then we just have our times 10 to the fifth. Now bring this other part down. Minus 3.84 times 10 to the fifth. Okay, so this is the part we have to do right here to get the same powers of 10 for adding and subtracting. Now, pull out, reverse distributive property here, pull out your powers of 10. I'm going to take this power 10 out and this power 10 out. I know I'm going to finish with the times 10 to the fifth. And then what do I have left? 924 minus 3.84. Okay? So when I subtract that out, I get 920.16 times 10 to the fifth. Look at all this good practice we're getting because this is not in scientific notation. So I want the decimal point to be right here. I want this to read 9.2016. If I go from where I want it to where it is, I'm moving 2 to the right, so I'm adding 2. So this becomes 9.2016 times 10 to the seventh. How much further? That many kilometers. Or in this case, if we wanted the standard form, we would move the decimal point over 4 times and then another 3, total of 7 times. 4, 5, 6, 7, and we get 92,016,000 kilometers farther. Again, ladies and gentlemen, efficacy of scientific notation. Scientific notation allows us to do some approximations, do some calculations with really large or really small numbers.